Hey, welcome to another Mercury live coding tutorial. In this tutorial I want to look at how we can use list functions to generate melodies. And then we can use those melodies in synthesizers for a bass synth and a lead synth and whatever we like. So in the previous video I showed that if you click on the help file, we will open the new Mercury documentation. And in the documentation, if you go to the reference, then there's a section called list functions, which is the section that you can use to find all the information about all the list functions that are available. So before I start coding a list for a melody, we first need a synthesizer to actually play a melody. So let's create a synth. I'll use a triangle wave shape this time. I will play 8 notes and I will set the note at note 0, 2, which is the bass note of the scale, and the 2 stands for the third octave. So we go from 0 to 1 to 2. So let's have a quick listen. So that's the sound of the triangle wave shape. So we've seen in a previous video that I can create a list. I can call that list melody, for example. And then I was able to create some melody by just typing numbers. And these numbers correspond with the semitone offset on the piano keyboard. So do you go from a white key to a black key, or do you skip all the way to the end? And then we can put that list in the note function, so the instrument knows that every time it is playing, it will step from the 0 to the 3 to the 7 to the 11. And then we can listen to the result. So the same as with creating rhythms, at some point you will have a very long list of numbers which you have to all type manually, and also you have to think of all these numbers. But the power of the computer is that you can actually use some algorithms to generate these melodies or numbers for you. So you can let the computer decide what the melody will be, and then you can listen to it and decide for yourself if you want to keep it or change the parameters to get some different output. So the first function I would like to use is a function that will allow us to generate notes randomly. And in the previous video we've seen that there's a coin function that will generate coin tosses, so a 0 or a 1. But in this case we want different numbers than just 0 and 1, because we want the numbers that fit in a scale. So for that we can actually use the random function. So the random function has 3 parameters. How long will the list be? What is the lowest possible number? And what is the highest? So for example, if I want to create 8 notes, then the first argument will be an 8. And if I want the lowest number to be a 0, then the second number will be a 0. And if I want the highest possible number to be 24, so 2 octaves higher, then I can type 24. And again, as with the previous video, we can use the print function to see what actually will be the output of this function. So let's have a listen. Now the random function will generate a random set of numbers every time we click play. So we will hear different melodies come up every time we play. Now currently all the notes that are randomly picked are possible to play. But as you've seen in the previous video about scales, we can set a scale to make sure that the random notes that are generated at least fit within the scale that we want to hear. So for example, I can say set scale, and then maybe I want to listen to a minor scale this time. So I can say set scale minor, and then when I hit play, every time the notes will be randomly generated, we will at least hear the notes that only fit within this minor scale. So you can hear that that becomes already quite more musical than it was before. So the nice thing is that if we create an extra synth now, for example, another triangle, maybe play it a bit slower, maybe quarter notes, and then we can use the same melody in a lower octave, maybe change the shape a little bit with a fade in, fade out, and we already can create a lot of variety by just clicking play and listening to what the random melody will be like. So besides generating notes randomly, there are also some methods that will help us to generate notes algorithmically, just like with the Euclidean rhythm. So one method that we can use is called the spread function. And this function is like a counter. So if I say spread 12, the output will be 0, 1, 2, 3, 4, 5, 6, 7, all the way up till 11. Which will be in total 12 values. But we can choose the lowest starting point and the highest ending point. So if I say start at -5, but then continue to 17, then the list output will be different. So let's have a look at what that list output will be. So you can see it starts at -5 and then goes to -4, but it will skip a few steps to get to 17, because it only has 12 steps to go, but the distance is too large. On the opposite, if I start at, for example, 1 and only go to 5, it will duplicate a lot of numbers, because it has to repeat itself in order to try to slowly get to 5 over 12 steps. So this could be an interesting source to generate melodies with, by slowly ramping towards some value or by quickly jumping from one value to the other. So let's create 8 notes and then ramp from 1 to 5. Or maybe ramp to 12. Or maybe ramp to 24. We can also ramp down if we swap the lowest number with the highest number and the highest number with the lowest number. So now that we've seen these two methods to generate some melody, we can already combine these by using, for example, the join function that we used in the previous video. So I can use the join function that, for example, starts with the spread function that generates 8 notes, ramping down from 24 to 0. And then I can create some random notes with the random function between 0 and 12. Some other method that we have that could be interesting is, for example, we can start with this spread operator, but then we can shuffle the list, so we can reorder the content of the list in a random order. So I can say shuffle. And so the interesting thing about this is that we will start with this basic pattern of notes that we know that will play, and then it will only reorder those notes. So it's not the same as random, because random will have an equal probability for all the values within that range. The next thing we could do is maybe create a separate list for the bass notes. And we can use the melody to create a bass line where the bass notes are basically the melody, but the notes are repeated for a longer period of time. So for example, I will start with the melody, but I will repeat the melody. I repeat it 8 times. So let me print the bass notes as well, so we can see what comes out of that. So if I click play, you will see that the bass notes is the melody, but then every number is repeated 8 times. Now we were not listening to this bass notes yet because I didn't change the melody name in the note function. So first we have to also change the melody to bass notes. And maybe I want to go to the 0th octave, so it's a bit more bassy sound. So slowly we can expand this melody with more functions. So some function could be that we want this same melody, but we want the inverse version of it. So I can make a new list called inv melody. Maybe I'll do with a capital M so it's clearly to read. And then I can say I want to invert the melody. So if the note is an octave, then it will become a prime, so it becomes a 0. If it's a 7th, then it becomes a 2nd. So basically the note is inverted to a lower part in the melody. So we can see what that looks like if I print also the inv melody. And I'll mute the instruments for now so we can just see what is printed. So you can see in this case that the 21 it become the 0 and the 0 is become the 21. So they are inverted in that sense. 15 became a 6 and the 6 became a 15. So this can be interesting to use as a starting point to create different phrases and then combine them in time. So I can make a phrase and that will be joining the melody and the inv melody. And then I can play the phrase. And I can play the bass notes still. So for now I want to leave it at this, but there are many more list functions to explore. For example, you can click on the tutorials and go to chapter 4. In chapter 4 you can find list functions for generating rhythms and melodies with some examples. For example, if you want to create something with drunk, or if you want to create chords. So go ahead and check those out. The other place you can find all the list functions, of course, is in the documentation. If you go to list functions in the reference, and then scroll through the page, you can find all the functions that are available with some small examples and explanation of what the arguments are. So that was it for this tutorial about list functions for generating some melodies. And in the next video we will look into using list functions for generating parameter modulation for other functions than just melodies or rhythms. So I hope to see you around for that one. Bye!